So logarithmic graphs, something to mention because we haven't really seen much of logarithms yet, but we'll get more into what exactly they are later on in the chapter. We're just going to learn how to graph them for this section. But logarithms are inverses of exponential. And does anyone remember what an inverse is? Like, what do I do to my ordered pairs if I want to find the inverse? I switch them. So imagine taking all of your x and y values of an exponential and just switching them and graphing that. So an inverse, all that means is switch x and y. And I think it's in 8.3, we'll learn how to actually do that algebraically, but we're just going to learn how to do it graphically for this section. And so when you're looking at these, so if I have, like, my first example is log 2 of x. If I were to plug in 1/8 here, log 2 of 1/8, how I find that y value is I think in my head, what power do I need to raise to 2, so this is like a question mark, to get 1/8? And that's what goes in this blank right here. So what do I need to raise the base, which is this 2? What power do I need to raise it to get 1/8? -3. And why is it negative? Because it flips, so it becomes 1/8, and then 2 to the third power is 8. So I would put a -3 here. Now I'm going to do the same thing for 1/4. So how do I get from 2, so log base 2 of 1/4? What power do I need to raise that to? -2, 1/2, -1. Anything, or whenever my answer is 1, what power is that always raised to? 0. 2 to what power is 2? 1. 2 to what power is 4? 2 to what power is 8? 3. Good. And then you will plot those points. Probably should have zoomed out a little bit more. So go ahead and plot those. Something about a logarithmic graph is in the exponential we had a horizontal asymptote. For this unit we will have, or for log graphs, we will have a vertical asymptote. So you'll have one at x equals 0. So I'm just going to scroll down and then we'll go to number 2 here in a minute. So it looks something like this. And you have a vertical asymptote at x equals 0. So now all of my domains and ranges will be switched because remember you're literally flipping x and y. So my domains and my ranges will be switched. So now, like in the exponential graphs, my domain was always -infinity, positive infinity. Well, now my range will always be -infinity, positive infinity. And then my domain will be from my vertical asymptote to positive infinity. My asymptote is at x equals 0. For increasing and decreasing, I still look at what my y value is doing to the right. So to the right, my y is going up, and so that means that it's going to be increasing. Then as x is going to positive infinity, my y is going to positive infinity. And now it's not going to negative infinity because it stops at 0. So I'm going to always put my vertical asymptote here. It's put there for us right now, but there may be some examples where we have to change it. So as x goes to 0, what is my y doing? Negative infinity. Good. So 1/2, I guess I'm going to write it like this. 1/2 to what power gets me 1/8? Would it just be what? 3. Good. Because when you distribute a 3, you distribute it to the top, to the numerator and the denominator. So it would be like saying 1 cubed over 2 cubed, which becomes 1/8. Okay, so you should have your chart filled out. Now I'm going to plot my points. Look something like this. I still have my vertical asymptote at 0. My domain is from where to where? Oops, that's a highlighter. 0 to positive infinity. My range is always negative infinity, positive infinity. Asymptote at x equals 0. It's going like this. Not a perfect picture, I'm just recreating it. Would it be increasing or decreasing to the right? Decreasing. As x goes to the right, or to positive infinity, my y goes where? Negative infinity. Then as x goes to 0, which is also my vertical asymptote, it's not always going to be 0, it's just going to depend on what your vertical asymptote is. My y does what? Positive infinity. Good. Okay, so here's just some notes. This is a parent function where we refer to this as our base. And our base will always be a positive number, so you'll never have negative. If it's negative, then it doesn't exist or it's undefined. And it will also never equal 1. Now, kind of like how in the last part of the section we wanted to find 2 ordered pairs, one making the exponent 0 and one making the exponent 1. So these this is kind of the same rules, but I'm gonna teach you 2 of them. Basically, and I don't think there's enough room to write this, but the first rule is anytime that you have a log with any base of 1, that always equals 0. So basically you want to make the inside stuff 1, whatever that is. So I'm going to put make inside equal 1. And then the second thing, the second ordered pair, and we're going to get some practice with this, so just put this in your notes for now and then we'll do some practice. The second thing is your log with any base of that base equals 1, so they cancel out. So you want to make your inside 1, and you want to make the inside equal whatever your base is. So example, log base 3 of 3 equals 1. Because it's like saying 3 to the first power equals 3. And this is like saying base to the 0 power equals 1. So these are raising your base to the 0 power and to the 1 power. So it's kind of the same idea or the same concept as the first part of the section, but it's just written in a different way. Now we have to make, instead of making the exponent 0 and 1, we're making the inside of the parentheses 0 and 1. Or 1 and base, sorry. Okay, some transformations, the same kind of rules. So your A, whatever number is in front, is always going to be a vertical stretch or compression. Remember, if it's negative, then it reflects the x-axis. I'm going to put down here B because it's not on here. That's a horizontal stretch or compression. It will never be negative, so remember talking about how it reflected the y-axis last time. You won't really ever have a negative x because it can't be negative inside, so we won't have a reflects the y-axis for this. H is going to be a left-right shift, and x equals h is my vertical asymptote. So now the stuff on the inside of my parentheses is going to be my asymptote, not the k. So the h is my asymptote for logs. The k was my asymptote for exponentials. And then k is up, down, shift. Okay, so looking at number 3, I'm just going to write out to the side log of 1 equals 0, log of b equals 1. My base down here. So those are my 2 ordered pairs that I want to find. And so, what x value, first of all, I'm just going to plug in x equals 1. So when I do that for number 3, log of 1 is always 0. So I have an ordered pair at 1, 0. What is the second x value that I need to plug in? 3. And when I plug in 3, I end up just getting 1. So I want to match this x. I want it to be 1, and I want it to be whatever my base is. And so in this example, my base is 3. And the reason why I do that is because if I were to flip my x and y and like rewrite it as exponential, it would be like saying 3 to the 0 equals 1, and 3 to the 1 equals 3. Because you're flipping x and y. That's what inverses are. So when I switch these, it's like saying, like my x is here and my y is here. So if I switch 0 and 1, and it's going to make more sense when we, in 8.3, when we convert exponential and logs, like we start switching them. So it will make more sense. For right now, know these 2 concepts, and then 8.3, it should make more sense. But basically what we're doing is we're raising our base to the 0 power and to the first power by doing this. So I'm going to plot these 2 points, 1, 0, and 3, 1. And I have a vertical asymptote at x equals 0. So I'm going to connect my dots. My domain is what? 0, positive infinity. My range is always negative infinity, positive infinity. Am I increasing or decreasing? And then positive infinity, negative infinity. Do I have any transformations? Yeah. I'm not going to scroll down, so you just put it where it says transformations. Horizontal stretch by 3. That goes down here. Okay, try number 4. Okay, for number 5, now I'm setting this x minus 1. So x minus 1 equals what two numbers? 1 and 3. Good, because I want it to equal 1 and then I want it to equal the base. So these are the two things I'm setting my stuff in parentheses equal to. So I want x minus 1 to equal 1, and I want x minus 1 to equal 3. And when I actually solve those out, okay, so what two x values do I need? If x minus 1 equals 1, then I'm going to plug in 2. I'm just solving this, so I add 1 on each side, so I need x equals 2, and then I need x equals 4. Can't really see that. So then 0 plus 2 is 2. 1 plus 2 is 3. Positive 1. Yes. So then I have an asymptote at x equals 1. So my domain would now be from where to where? 1 to infinity. Now these are both say 0, so I need to fix them because they're wrong. So infinity and then 1. Or 1 and infinity, either one. And then lastly, what are the transformations for this one? Horizontal stretch by 3. I'm just abbreviating. Right 1 and up 2. Okay, so in order to keep this consistent, I don't want to blow your brains too much, so I'm just going to say that we're going to stick with keeping it equal, x equal to 1 and to the base. Now, if you think about it, if you raise 1/3 to the negative 1 power, then you could put x equals 3 here, and it could be 3 negative 1. But I'm going to keep it consistent. So I want x to equal what two numbers? 1 and then 1/3. When x equals 1, y is 0. When x equals the base, y equals 1. And you're just going to plot the fractions to the best of your ability. So 1, 0, and 1/3, 1. So what do you notice about the direction of this compared to the other ones? And to the right it goes down. So these would be decreasing. So anytime you have a fraction, it's going to be decreasing. Anytime you have a number greater than 1, it's going to be increasing. So my asymptote, still x equals 0. domain 0 to positive infinity, negative infinity, positive infinity. Decreasing to the right, it's going down, and then at 0, it's going up. For number 7, I'm still going to plug in 1 and 1/3, but now I'm shifting up 1 point. So what would my ordered pair be? What would my y value be at 1? 1. And then at 1/3. 4/3. Fractions, people. Because I'm adding 3/3 to it. So 1/3 plus 3/3 gives me 4/3. Yes. Love it. That's the same thing as 1. Do what? Did you ask a question? So for this, I'm just adding. So log 1/3 of 1/3 becomes 1. Oh, shouldn't it be 2? It should be 2. Who said 4/3? Shame on you. Shame on me for believing you.
What are you talking about? Yeah, it's a fraction.
I just got too excited about fractions. I'm sorry. It was the next.
For the first time, I'm a retard over here. Had 2. But how many people actually die?
Y'all are right. I'm wrong. 1 plus 1 is 2. Simple math is hard sometimes. No, it still goes down.
What?
It still goes down.
No, I was like, if you would have done it the 4/3, it would have.
You're right. You're right. And transformations for these, I didn't say this. Horizontal compression by 1/3. Horizontal compression by 1/3, and then up 1. Yes. They are. Oh, on number 8. 0 is the asymptote. So how do I choose the 2 points? I need to set x plus 2 equal to 2 numbers. So I need x plus 2 to equal 1, and I need x plus 2 to equal 1/3. This is where the fractions come in. Yikes. So, no, we shouldn't skip this. So this one's easy. I'm going to come down here. My first x value, if I subtract 2 on each side, is -1. Because you just subtract 2, x equals -1. And so when I plug in x equals -1, this whole thing ends up going away and it becomes 0 minus 1. So -1, -1.
Why wouldn't you like -1 minus 1 be -2?
Because when you plug in -1 here, it becomes log of 1, and log of 1 becomes 0. The second ordered pair, this is where the fractions come in. If I subtract 2, you could just do it in your calculator and take the easy way out, or you could make your own fraction. If I rewrote 2 as a fraction with it could be 2 over 1. It could also be 6 over 3.
Okay.
I'm changing it to 6 over 3 because I wanted to have the common denominator with 1/3. I just am deciding like what x value to use first. I haven't solved it yet. So then this becomes x equals 1/3 minus 6/3 is negative 5/3.
Good job.
But just choosing the x value is the only hard part because when I plug that in, it becomes 1, and 1 minus 1 is, is 0. Yeah.
You've learned wrong all these years.
I know, I don't know. So my 2 ordered pairs are negative 1, 1 and negative 5/3, 0. So I'm going to plot those points. Negative 5/3, 0. Like around here. Where's my asymptote? Negative 2. Right here. Cutting it close. So then it looks like this. Anytime you have a fraction, it's decreasing. Also, the number or the point that's closest to the asymptote will be the one that lines up with it, like the direction. So asymptote is x equals negative 2. Domain, negative 2 to positive infinity. Range, negative infinity, positive infinity. I need to change these zeros to be what? Infinity and negative 2. I changed them. So to the right, it's going to negative infinity, and then at negative 2, it's going to positive infinity. And then my transformations, let's just say them out loud. Horizontal compression by 1/3, left 2, down 1. Good.